Hello guys, welcome to my channel. In this video, I'm going to show you how to simplify algebraic expressions by combining like terms. First, I will show you how to identify like terms by very simple fruits method, and then I will expand it to real algebraic expressions. Finally, I will solve some examples to ensure you totally understand it. So let's start together. This is an algebraic expression, which is a combination of terms by operations like addition, subtraction, multiplication, etc. So an expression can be a combination of both variables and constants. For simplifying the algebraic expressions, first we need to identify like terms and then combining together. Let's imagine we have an expression which instead of variables we have fruits, and we want to simplify this expression. As I said, first thing is to find like terms, so we start find like fruits. In this expression we have 2 apples plus 3 bananas plus 4 apples plus 2 bananas plus 5 oranges. So we have apple, banana, and orange as variable like x, y, and z. And the real expression is something like this: 2x plus 3y plus 4x plus 2y plus 5z. Now we want to simplifying, so like terms are terms with the same variables or fruits. In this expression, for the first term, we have apple as a variable. So for finding like term, just like this term, we need to looking for another terms which are including apple, and here we go. So both terms are similar. So they are like terms because both have apple as a variable. And we do the same for another fruit. So here we have 3 bananas and we are looking for another terms including banana, and here we go. So both terms are like terms. And the last one is 5 oranges. And as you can see, we don't have any oranges here, so we need to keep as it is. Now we need to combine these like terms. So 2 apples plus 4 apples equals 6 apples. 3 bananas plus 2 bananas equals 5 banana. Okay, let's just consider it as a banana. And we have 5 oranges, and because we don't have any other terms which including orange, so we have to write it by itself. So our simplified expression is this, and the real expression is 6x plus 5y plus 5z, because we consider apple as x, banana as y, and orange as z. So this is our simplified real algebraic expression. Now let's simplify another expression, and as you can see, we have variables with powers. So I want to explain with fruits again to make sure you understand it better. Let's imagine the power as a hat for our fruits. So our expression is something like this: 8 apples with hat, because I consider 2 as a hat, and as you remember, x was apple, so we write 8 apples with hat plus 3y squared. Y was a banana and I consider power as a hat, so I write 3 bananas with hat minus 2 x squared is minus 2 apple with hat plus 5x is 5 apple minus 3y minus 3 banana, and x was apple minus 2y squared is minus 2 banana with hat. And now we want to find like terms. So we start with the first term. In the first term, we have 8 apples with hat. So for finding like terms, just like this term, we need to find another terms including apples with hat. And here we go. This is a term with apple with hat. So both terms are like terms. And another terms is 3 banana with hat. So for finding like terms, we need another terms including banana with hat. And as you can see here, we have -2 banana with hat. So both terms are like terms. And the next term is 5 apples. So 5 apples, we need another terms including apples, and here we go. So both terms are like terms. And here we have -3 bananas, and as you can see, we don't have any terms including banana, so we need to keep it as it is. And now we need to combine like terms. Okay, 8 apples with hat -2 apples with hat. 8 minus 2 equals 6 apples with hat, and just consider it as a hat. And next like terms are 3 bananas with hat, and the like term is -2 bananas with hat. So +3 minus 2 equals +1, and we don't need to write 1, so we need to write variables or fruits. Banana with hat. And the next term is 5 apples plus 1 apples, and you know that when we don't see any number here, we just consider it as 1. So 5 apples plus 1 apples equals 6 apples. And for the last terms, we have -3 banana. And here is our simplified expression. And the real expression is something like 6. And you remember that apples with hat is x squared plus banana with hat y squared plus apple was x, so 6x minus 3 banana was y, so -3y. And this is our final simplified expression. Now let's simplify this expression. In this expression, we have new terms including multiplication of 2 or 3 variables. And if I want to explain it with first method, I must say that when you see some variables multiplying by each other, just like 2xy or here xyz or x squared y, you quickly imagine them in a basket. And then for finding like terms, starting looking for another baskets which are including exactly the same fruits with or without hat. And you know that when I say fruits, I mean variables, and when I say hat, I mean the powers or exponents for the variables. So let's consider the expression with fruits. As you remember, for x we have apple and y as a banana, and x squared as apple with hat, and y squared as a banana with hat, and z as orange. So our expression with fruits is something like this. Now let's find like terms. For finding like terms, we need to start with the first term. For the first term, we have 2 variables or fruit multiplication by each other, so we need to consider it in a basket. And for the next terms, we have apple with hat and banana, so we need to consider it in basket. And as you can see, for the all terms of the expression, we need to put them in a basket because all of them including 2 or 3 fruits multiplication by each other, so we need to put them in a basket. And then for finding like terms, we need to look at the first term. In the first term, we have a basket including apple and banana. We are looking for another basket including apple and banana, and here we go. This is a term including a basket with apple and banana in it, so both terms are like terms. And the next term is a basket including apple with hat and banana. So we are looking for another basket including apple with hat and banana, and here we go. This is a basket including apple with hat and banana, but as you can see, both terms are slightly different with each other. In this basket, we have first apple with hat, but in this basket, we have first banana. Both terms are like terms because if you imagine 2 times 3 or 3 times 2, both of them equals 6. It doesn't matter which of them is the first in order. Both terms are like terms. And if we imagine x as a 2 and y for 3, xy equals yx, and both terms are like terms. So the order of variables doesn't matter in multiplication. So both terms are like terms. And we are continue and we see another basket including apple and banana with hat. So we are looking for another basket including apple and banana with hat, and here we go. So both terms are like terms. And for the last term, we have 4 apple, banana, and oranges. And because we don't have any terms including the basket with apples, banana, and oranges, so we keep it as it is. Now let's combining like terms. 2 apple banana minus apple banana, and remember that when we don't have any number here, we consider it as 1. So 2 apple banana minus 1 apple banana equals 1 apple banana. And for the next term, we have 3 apple with hat banana plus 8 banana apple with hat. So positive 3, positive 8 equals positive 11 apple with hat and banana. And here we have minus 5 apple banana with hat, and here we have minus 7 apple banana with hat. So minus 5 minus 7 equals minus 12 apple banana with hat. And the last one is positive 4 apple, banana, and oranges. And if we want to write real expression, we need to write xy plus 11 x squared y minus 12 xy squared plus 4x, y, and z. So this is our simplified expression. Now let's simplify this expression for more understanding. The first thing we need to do is to looking for new variables which are multiplication by each other. So we need to put them in a basket. Here we have one basket, here we have another, and here we have another one, and here. Now let's finding like terms. For the first term, we have x squared. So we are looking for another terms including x squared. So we have, as you can see, we don't have any terms including x squared, so we need to write it by itself. And the next one is positive 3xy. So we have a basket, so we need to looking for another basket which is including exactly x and y in it. So here we have another basket including x and y. So both terms are like terms. And for the next one, we have a basket including x squared y. So we need to looking for another basket which is including exactly x squared and y. And here we have a basket which is exactly like this basket. So both terms are like terms. And for the last one, we have positive y squared. So we don't have any y squared, so we need to keep it by itself. And now let's combining like terms. So we have x squared by itself, so we need to write it by itself. And here we have 3xy with positive 4xy, so 3 plus 4 equals 7xy. And here we have minus 2x squared y with minus 3x squared y, so minus 2 minus 3 equals minus 5x squared y. And here we have 5y squared by itself. And this is our simplified expression. Okay, the next one, we have variables multiplying by each other, so we need to keep them in a basket here and here and this one. And now let's start with the first term. We have 5x squared. We looking for another terms including x squared, and here we have x squared, so both terms are like terms. And here we have a basket including x, y, z, so we need to looking forward another basket with x, y, z, and here, so both terms are like terms. And here we have another basket with x and y in it, so we are looking for another basket including x, y, z here. So both terms are like terms too. And now let's combine like terms. Positive 5x squared minus 4x squared, positive 5 minus 4 equals positive 1, and we don't need to write 1. And the next one is 1 xyz plus 3 xyz, so positive 1 plus 3 equals positive 4 xyz. And here we have minus 2xy, and here we have positive 2xy, so minus 2 positive 2 equals 0, and 0xy equals 0, because 0 multiplying by any numbers or variables equals 0, so we don't need to write it here. So x squared plus 4xyz is our simplified expression. And the last example, remember that when we have two variables with different power, both variables are not equal to each other, we don't consider it as a like term. And if you imagine them as a hat for our variables, it's something like this. Apples with blue hat is not equals to apple with green hat. Okay, now let's start to simplifying this expression. And as you can see, we don't have any variables multiplying by each other, so we don't need to keep them in a basket, and we just start by looking for another terms, which is exactly like this term, x squared. We need to looking for another terms exactly with x squared. Here we have x, but the power is 3, and both terms are not like terms because the power of variable are different. So we need to continue for looking for another terms, and here we go. This is a term with the variables with hat or power are exactly like this term, so both terms are like terms. And for the next one, we have positive 3y squared. We need to looking for another y squared here. So both terms are like terms too. And here we have minus 4x the power of 3. So we need to looking for another variables with the 3 in a power, and here we have x the power of 3, and here we have x the power of 3, so both terms are like terms. Now let's combining these like terms. 1x squared plus 3x squared equals 4x squared. And here we have 3y squared with minus 4y squared, positive 3 minus 4 equals minus 1y squared. And here we have minus 4x to the power of 3 plus 5x to the power of 3 minus 4, positive 5 equals positive 1x to the power of 3. And this is our simplified expression. Thanks for watching this video with me. Don't forget to like, share, and subscribe for more math hacks and tips. Until next time, happy mathing!